Hello all, welcome to my channel. Uh, I'm back with another video, and this video will be part of the series that we are doing on the solutions related to the 5 challenges of Spark, namely shuffle, spills, queue, storage, and serialization. So in this video, we will see how we can handle the issues related with shuffle. So let's get started. So in Spark as well, in Spark, Shuffle is a scenario where data is moved between the executors or worker nodes from one particular executor to other executor, and that is required in cases we have a large uh, data set that needs to be moved. The reason for that might be a wide transformation like join or group by, which causes data to be present with the same key should be present on the same executor. But in an initial distribution, that is not the case. For example, let's say this executor holds data for keys which have, let's say, ranges from A to F, while in this one it holds the key for uh, ABCD as well as, let's say, XYZ. And but while we do an aggregation or a group by, let's say we want all the keys of A, uh, key all the rows having a key of A in one, B on other one, or let's say D on other one. So it has to fetch data from all these three, and that's a n cross n connection gets created. So that is something which is not good in case the shuffle happens. It's very expensive because it is IO bound. To solve this problem, Spark team also built a product called Spark's inbuilt shuffle. So what they did is they said that executors will hold the memory blocks and they will control the life cycle. But that was still not very good solution because if executors died, the shuffle data was getting lost. Hence, Spark came with a solution. The open source community built in Spark external shuffle service, which is a long-running aux process on the workers. So when we launched with Spark with an external shuffle service, there is a service which gets launched on each of the nodes on which the executors come up. So let's say if one node has 5 executors, and let's say the whole application is running on, let's say, n nodes, so only n external shuffle services are created, not for each executor, but one shuffle service per node in the cluster. So it will launch a service and that will manage the shuffle data. So if we have to enable it, we have to say spark shuffle service dot enabled is equal to true, and this is only available for yarn mode, not for Kubernetes mode. Kubernetes mode, you need a different approach. You need to have a daemon set by define. You have to define the daemon set, and that should run on each of the what do you call service, each of the nodes where the executors might come up. So the executors, what happens is when enabled, the executors will write shuffle data to the local disk, and the ESS, which is external shuffle service, serves this data to other executors. So in this case, if you see here, what is happening? Each executor, let's say if these are the executors, they are trying to get data from these three. So instead of, and let's say if these three were on 3 different nodes, so each one of them is independent, talking to independently. But let's say if some, by some means, if they all three were on one particular node, and there was an external shuffle service enabled, so these three will not talk to these three, but they will talk to only one connection. So only we'll have three connection to that particular service, and that service is Spark's external sub service, and they will serve the responses. They will serve the shuffle data to the other downstream consuming executors. The benefit of this will be that if you see, earlier executors were talking to other executors, but let's say if we have DRA, which is dynamic resource allocation, so the executors may come and go. The moment they go, their shuffle data is also lost, so it has to be recalculated, and that's where this helps. But because the ESS manages the shuffle data, so once shuffle data is available to the ESS, it doesn't means that executor which wrote the data doesn't have to be live, it can go away, and hence it slightly improves the shuffle process. But this solution has a challenge that it is the shuffle service runs on the node. So if the node itself goes away, again Spark has to recompute everything from the beginning. So this slightly improves upon, I mean, it's like it improves upon something like it is in means if there was from getting the data from executors, it is better to get the data from the node via the external shuffle service. So that has slightly improved the resiliency of the application. Then there was uh, this was from Spark's external service. Then there were certain shuffle services built. For example, there is an yarn-based shuffle service as well that can be used, but it was formalized with ESS in 2014, and it runs an auxiliary service on Yarn's node manager. So this was there. Then a few other companies, for example, Facebook, they created a disaggregated shuffle service called Costco, and it was designed to elevate the small I/O and write amplification issues that were there. It used a in-memory write-ahead buffer to per reduce partition, and this was an attempt to solve the certain challenges of the shuffle service which was there with Spark, and this used to run as an external service. So this is not linked to the uh, this was not linked to the main process of Spark application. Also, it has an overhead of running its own scheduler as well as metadata shuffle service. Uh, then, based on this, they also launched, after Costco, they also created a newer version of Costco called Riffle. This was also trying to reduce the shuffle problem. At LinkedIn, there was a service which called Magnet, which that was released, and this later on it was officially accepted as the Spark solution to external shuffle service. Uh, Uber also launched a service called GS, which is their their reverse shuffle service or paradigm was launched. They also uh, they were not using SSD as the main solution. Then Alibaba open sourced Calibon. So Calibon is another columnar shuffle service which runs external to the cluster, and they open sourced it, and this is one of the famous ones as of now. Tencent also launched one external service called Unifil, which is similar to Alibaba's Calibon. So all these like Unifil, Calibon, GS, all those are push-based shuffle where the Spark executors will push the data of shuffle data to these clusters like shuffle client to for a write. For example, this is in Spark uh, driver. So Spark driver will create a shuffle client. It will talk to the shuffle servers cluster. It will send the data there, and the executors, which is shuffle client, which needs that shuffle data, will call the shuffle services cluster and then get the uh, data from that particular service. So the life cycle is broken. So once the executor writes the shuffle data, its job is done. It can die as well, and then the data will still be available for others to consume. So this was all about different shuffle services that were created. In our next video, which will be the part two of this video, we will talk in detail of Calibon that that we can use to reduce the shuffle. And uh, there is a summary table as well here, which does try to compare few of the shuffle services which are there and their pros and cons. So the reason why I only will be creating a video on Calibon, not on others, is because of the limitations you see. So the built-in shuffle service does not support any accelerator. It does not have a columnar data supports. Spark external service is dependent on the nodes. Again, it is not does not support accelerators. Yarn's external service is also Yarn dependencies there. Costco does not support any accelerator. Riffle does not support any accelerator. I will also have a video on accelerator, which is the solution to the problem of skew, shuffle, as well as JVM issues that are there. So if you see the last two, Unifil and Calibon, these are the two shuffle services which stands out, and can be used in different scenarios. The reason I chose to make a video only on Calibon because it supports Flink as well. It supports Data Fusion Comet as well. This was the most versatile supple services. So if you know this, you can implement this in Flink or any other distributed compute which has a shuffle challenge. And hence that's why I will make a video on this. So in the next video, which will be the part two of this video, we will see how Calibon helps us in reducing the shuffle. So stay tuned and do subscribe to the channel. Thanks.